This video is on Unit 2, Chapter 5, Solving Quadratic Functions, Lesson number 4, Solving Quadratics by Square Roots. In the notes here, under Solving Quadratics by Square Roots, in a quadratic equation of the form ax squared plus c is equal to 0, it can be solved by using square root property. Notice here that there is no bx. There's no bx term. There's no middle term. The square root property says that if x squared is equal to n, then x is equal to the positive and negative square root of n. And I'll explain more about that here in just a second. The steps tell you to isolate the x squared. Secondly, take the square root of both sides. And then thirdly, simplify the radical. Don't forget a positive and a negative to indicate both answers. So in the directions here, it's telling us to solve each equation using the square root method. Question number 1, x squared minus 64 is equal to 0, is one that could be factored. And back in that lesson with difference of squares, I told you there were other methods that would work faster and easier. This is one of them. So when you have x squared minus 64 is equal to 0, again, the one thing you want to notice is that there is no bx term. So we're going to isolate the x squared, which means we're going to add the 64 to both sides. So we'll get x squared is equal to 64. From here, we're going to square root both sides of the equation. And when you square root a square, it leaves you with just x, and then the square root of 64 is 8, and we end up with a positive and a negative 8. Now let me show you why it's a positive and a negative. If I substitute this back into the original, x squared minus 64 is equal to 0. If I plug in the 8 squared is a positive 64, minus 64 gives me 0. And if I square the negative 8 squared is a positive 64, minus 64 is equal to 0. So when we square root both sides of an equation like this, you end up with a positive root and a negative root. All right, let's look at number 3. Number 3 says 81x squared plus 5 is equal to 21. So the first step here is to take the x squared term and get it by itself. We want to subtract the 5. 21 minus 5 is 16. Then we're going to divide by the 81. Now this one's going to be a fraction, but don't freak out yet. When we square root both sides of this equation, we get x equals, the square root of 16 is 4, the square root of 81 is 9, and don't forget the plus minus, and there's your solution for number 3. The same thing is going to happen on number 2. Let's look down at number 4, though. Number 4 says 8x squared plus 1 is equal to 17. Same process. We need to get the x squared term by itself. We're going to subtract the 1. 17 minus 1 is 16. Divide both sides by the 8. 16 divided by 8 is 2. And then when we square root both sides, what you're going to find here is that we cannot take the square root of a 2. So the answer for this is a positive and a negative square root of 2. So what we've learned so far in solving quadratic equations is that our answers can be rational and real, like example 1 and 3. They can also be irrational, like example number 4. Let's look at example number 6. 9x squared plus 3 is equal to 111. We're going to subtract the 3. So we get 9x squared is equal to 111 minus 3 is 108. And then divide by 9. So we get x squared is equal to 12. 108 divided by 9 gives us 12. Again, we're going to square root both sides. And we get x equals a positive and a negative. Now, 12 is not a perfect square, so I need to take the square root of 12 by simplifying. So we're just going to simplify this. And again, you're using whatever method you prefer. I'm going to change this into a 4 times a 3, take the square root of 4 and get 2. The 3 stays under, and my answer for number 6 is a positive and negative 2 square root of 3. So again, our solutions here are irrational. You're just going to have to simplify those radicals. The same thing is going to happen on 7, 8, and 9. I'll look at number 9 just because it has a fraction in it. We've got negative 1/2 x squared plus 1 equals negative 39. So I'm going to subtract that 1. Negative 39 minus 1 is negative 40. And then to get the x squared term by itself, you can divide. You can look at it like you're dividing both sides by negative 1/2. I'm going to multiply both sides by negative 2. Negative times negative is a positive. The 2's cancel. And I have x squared. Multiply the other side by the negative 2, and I get 80. And then I'm going to square root both sides. And again, I'm going to have to simplify my radical. So 80 is going to be 16 and 5, which is going to give me 4 radical 5 for my solution here. And again, don't forget the plus minus. All right, let's jump over to the next set. So solving quadratics by square roots where we have imaginary solutions. So looking at number 10, x squared plus 81 is equal to 0. We're going to subtract the 81. And we get 0 minus 81 is a negative 81 on the right side. And when we square root both sides here, what we have is a negative under the radical, which gives us an I. So x equals a positive and a negative. Square root of 81 is 9, and don't forget the I. So now what we have are solutions that include your imaginary numbers. Let's look at number 13. Example number 13. We're going to subtract the 13 from both sides. We've got to get the x squared by itself. 1 minus 13 is a negative 12 square root. And we get x equals positive and negative. When we take the square root of negative 12, I'm going to make that a 4 and a 3. So 2i radical 3 for my solution on number 13. So this is one that has radical and imaginary in the answer. So be careful there. I have included a couple of extra examples that I wanted to share. And in example number 13 or 16, I've got x plus 5 squared is equal to 49. Now, what we can do here is we can square root both sides of this equation. So I'm going to square root both sides. And what happens here on the left side of this equation is the square and the square root cancel. Okay. Now, I realize in the steps that you were given in the beginning of the notes, it said to get the x squared term by itself. X plus 5 is your squared term, and it's already by itself. So that's why we can go ahead and square root both sides. So then we get x plus 5 equals, again, we cannot forget the positive and the negative. And the square root of 49 is 7. Now what we have is a statement that says x plus 5 is equal to a positive or a negative 7. So what we need to do is solve both situations. If x plus 5 is equal to 7 or x plus 5 is equal to negative 7. Subtract the 5. 7 minus 5 is a 2. And again, subtract the 5. Negative 7 minus 5 is a negative 12. So my two solutions for number 16 are negative 12 and a positive 2. Number 17 is very similar, but the first thing that we need to do is subtract the 4. So that's going to give me 2x minus 3 squared is equal to 85 minus 4 would be 81. And then again, we're going to square root both sides. And we get 2x minus 3 is equal to a positive and a negative 9. And we really don't need those parentheses there. I'm going to erase those just because I don't need them. But at this point, we just need to set up our two equations. So 2x minus 3 is equal to 9. 2x minus 3 equals negative 9. And then solve. Add the 3. 9 plus 3 is 12. Divide by 2, and we get x equals 6. Again, add the 3. Negative 9 plus 3 is negative 6. Divide by 2, and we get negative 3. So we got a negative 3 and a 6 for our two solutions on number 17. Now, I showed you these two, and in both examples 16 and 17, we came out with rational, real solutions. Please understand that even in these types of equations, we could have irrational answers, we could have imaginary answers, imaginary solutions, not just nice, pretty integer answers. So those are your notes for Chapter 5, Lesson number 4, Solving Quadratics by Square Root.